Good evening and welcome back. Tonight we're going to be talking about domain and range of functions. And domain and range is a concept that is pretty solid to get once you understand the basics behind it. So first let's discuss a little bit what domain actually is, what the definition is of domain. And the definition of domain is all possible functions or all possible x values that a function has, or a graph, or a line, or a curve. Okay? So if we're looking just purely at a function, what we're talking about is an equation, some sort of f of x, right? Some equation. And what we talk about that is it's kind of like a machine, right? And where you take these x values and you put them into your machine. And your machine is your f of x, right? And out pop the y values. Okay, so this is any general function that you may have. And so what we're talking about domain. We're talking about all possible x values for a function or graph. Okay, that's all possible inputs we can put into this function to get a y out. Okay, so if we're looking straight just at some examples, because I know a lot of you have seen this in class already. If we're just looking at this example, because domain is the x-axis, okay, when you talk about domain, you look at the x-axis, okay, we just want to look at this. How far to the left does it go, and how far to the right? Okay, just on this x-axis. So if we're talking about the very beginning here, well, this is the farthest left, this point right here, this 0 point. That's the farthest left my function actually goes. So that's going to be in my domain, right? That x value there. Okay. And the farthest right this function goes is this value right here, the 6. Okay, the point 6, 7. So that's going to be the farthest right of my domain. That's going to be the highest value. So the domain is everything here in blue, all these x values. Okay, that's 0 all the way to 6. Okay, so then I can denote my domain as going from the value 0 to the value 6 and everything in between, because all these x values, we can put 3.5 in and we'll get a y value out. Okay, so 3.5 is on my curve. So all of these x values here, everything from 0 to 6 is in there. So if you want to talk about specific denotation, the math denotation for that is going to be the lowest value, and then you say is less than or equal to, and domain is talking about the x-axis, so that's going to be x, which is less than or equal to 6. And what this specific math denotation says is that x is greater than 0, right, or equal to, and x is bigger than 0. It starts at 0 and it gets bigger. Okay, that's all my domain. And x is less than or equal to 6. Okay, so x is basically between these two values here. Okay, and that's the domain. Now range is going to be talking about the y's. Okay, range is all about the y-axis, y values. So if we go back to this denotation of functions here, this what we put in, the x values are the inputs into our function, and out pop these y values, then the range is going to be all possible y values. Okay? So the range is going to be these things here. What comes out? Okay. So if we go back to our example here, our range starts right here. This is our first spot, this one right here. Okay, this 1. All right. And then the highest possible range here is this one up here. Okay, the 7. So that's the top. And because we have a line here, a curve, it's going to include everything in between. Everything. Okay, so there's my range. It goes from 1 to 7. Okay, from 1 to 7. And again, the math denotation here is going to be 1 at the lower end, less than or equal to y, less than or equal to 7. Okay, and that just says that y is greater than or equal to 1, and y is less than or equal to 7. Okay, and it is greater than or equal to 1, and less than or equal to 7. It does not go above 7. Okay, this function stops right here. Okay, and so that's domain and range for this function. And this happens to be an exponential. But really, by now we've covered linear, quadratic, and domain and range is part of all functions. Okay, so really we can talk about the domain and range of a whole bunch of different functions now. So the next example we're going to look at is this linear. Okay, this linear function here. So if I want to know the domain, okay, the x of this linear function, we're going to start at the lowest possible end, okay, the negatives. How far to the left does this thing go? And you'll see the leftmost point is right here. Okay, it's this point right here. And if we draw a line to the x-axis, you'll see the x value is -4. Okay, now let's look at the rightmost value, the farthest to the right on the x-axis. And you'll see it's right here. So let's draw a line to the x. And there's the leftmost or the rightmost x value. Okay, and because it's a solid line here, it's continuous. Everything in between here is part of that range. Everything. So that's going to mean that our range, our domain is going to be from -4 to 2. Okay, so the denotation for the domain there is going to be -4 is less than or equal to x, which is less than or equal to 2. Okay, now let's take a look at range again. Let's take a look at the y values, the range here. Okay, so range is y, and let's start from the bottom. Okay, this is the lowest most point on this function, this line segment. Okay, and it happens to be the y value of -3. And let's look at the highest point, the tallest, farthest up on this line segment, this function. Okay, and it's right here, so we'll trace back to the y-axis, and it's the point 1, it's the y value 1. Okay, so because again this is a line, a continuous function, and not points, but a whole line, it's everything in between there, everything. So my range is going to be from -3 to +1. Okay, or specific denotation is going to be -3 less than or equal to y less than or equal to 1. Okay, and there's the range of that function. Okay. Now, let's take a look at a quadratic. Okay, quadratic. So here I have a quadratic function. Okay, and it's got endpoints here and here. Okay. And we're going to try and find out the domain of this function, all possible x values. Okay. So let's go to the farthest point on the left of this line, the farthest left. And draw just a little dotted line all the way down to the x-axis, and you'll see that the farthest left value here is -5. Okay, and then let's go to the farthest right value. okay? And it's this point here, so draw down to the x-axis. We've got this right here, positive 5, okay? So this is a continuous curve, okay? It's not just points, it's a line, everything in between, okay? All the decimals, all the halves, all the quarters. So everything here is part of the domain. All those values on the x. So it's going to be from -5 to +5. And specifically denotating that for math, it's going to be -5 is less than or equal to x is less than or equal to 5. Okay. Now let's take a look at range. Let's take a look at our y range. Okay. And so I'm looking for all the y values. Now let's look at the highest point. And this is where it may get a little interesting because the graph goes up on both sides of the y. So you have to, let's start over here. Okay, what's the highest point on this side? It's right here. And if we trace that back, we'll end at +6. And if we do the same thing on this side, it ends at the same point, +6. Okay, so that's the top value for my range. And what's the lowest point? Where I can see, because the y-intercept here is touching at 1, but it doesn't go below that, I can see that that's going to be my lowest point. So the range, again, because this is a continuous function, it's not just a bunch of dots, it's a line, a curve. Okay, we're going to get everything in between there. Okay, all those y values are part of the range. So the range is from 1 to 6, or 1 is less than or equal to y is less than or equal to 6. And that's the range for that function. Now, during this video, I've been talking about continuous, right? Because it's a line, because it's continuous. But let's take a look at an example that may not be continuous. Okay, let's take a look at just a collection of points on a graph. Okay, collection of points. Okay, so you can see my graph has this point, there's one down here, 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 and here. Okay, and that's just going to be my collection of points. And I want to know what the domain of this graph is. Okay, what is the domain? Well, the domain is all possible x values. Again, so we're going to be looking at the x-axis for domain. Okay, and down here I have my domain. All right, so if we're looking at that, let's start with one of these points and draw. We're just going to draw a dotted line all the way down to the x-axis, and we'll see that that's the point -4. Okay. But because we have points, we're going to do the same thing for all of them. Draw to the x-axis, that's the point -2. Right here, we have the point -1. Okay, and then over here, we have the point 2, and right here, we have the point 3. Okay, but because there's no line or curve connecting these dots, nothing in here is going to be included. Okay, nothing between -1 and -2, or between -2 and -4, or between 2 and 3 is going to be included because we don't have a line connecting these things. So my domain is going to look a little different this time. Instead of from this to this, I'm just going to get a collection of points. Okay, so the domain is just going to be -4, comma, -2, comma, -1, comma, 2, comma, 3. And that's it. That's my domain. It's just those x values, nothing else. And we can do the same thing for the range. We can do the same thing for the y values. Okay, and if we look at this, all right, we're going to trace this first point over to the y-axis, and you'll get the y value +5 there. That's part of my range. What about this point? Well, that's the y value -3. How about this one? +1. This one, +2. And this one, -1. Okay? But again, because this is not continuous, because there's just a collection of dots and no lines connecting them, no curves there, okay, then we're just going to get points. We're not going to get anything between here, just 5, 2, 1, -1, -3. You'll see that -2 is not in my range because there's no point that has that as a y value. So my range here is going to be -3 right there, comma, -1, comma, 1, comma, 2, comma, and this one way up here that's kind of off the screen, this +5. And that is all of my range right there. Okay, so now you've seen some examples of continuous ranges, continuous functions, and what their range and domain are, and non-continuous graphs and what their range and domains are.